neutrons. Don't forget that whenever we have an element, we have the atomic number, that's the number of protons, and we have A, the number of nucleons. Now, if we're talking about the size of a nucleus, then we're not really concerned about the number of protons because we have protons and neutrons in a nucleus. So if we have a helium nucleus, 2 protons, 2 neutrons, A is going to be equals to 4. So is there a way that we can calculate the radius of a nucleus? Now, because nuclei are generally spherical in shape, and it figures that, well, the number of nucleons is going to be proportional to r cubed. To put it the other way round, the radius of a nucleus is going to be proportional to the number of nucleons to the cube root. Naturally, we need a constant in here, and we call this constant R0. Now, just to be clear, R0 is just a constant. Now, I say it's a constant, in reality it changes quite a bit, but at A level we are going to call it a constant. This constant is in the order of femtometers, as is to be expected. What we really care about is comparing different nuclei. So if we rearrange this to make the constant the subject, then we end up with R0 equals the radius of the nucleus divided by the number of nucleons, or the mass, to the cube root. So we know that whatever values we have, that is always going to be true. Can we draw a graph of this? Yes, we can, so long as r is on the y-axis, a to the third is on the x-axis. Yeah, we're going to get a nice straight line where the gradient is equal to r0. But there is a more useful way we can represent this graphically, and that's by taking logs. If you don't know how to take logs, have a look at my proportionality and graphs video. Take the log of r, that's going to be equals to the log of r0 plus a third log a. So there's 2 log identities that we've used to get from here to here. So if we draw a graph of this now, we can have log of r on the y-axis, log of a on the x-axis, and again we are going to get a straight line, but it's not going to go through 0. The gradient of this is going to be equals to just a third, and the y-intercept here is going to be the log of r0. Hope you found that helpful. If you did, then please leave a like, and if you have any questions or comments, then please leave them